Dear students, let us discuss some more examples. Note. Integral e raised to x into some function f of x is integration by parts. Here, we take f as first function and e raised to x as second function. So that this is first function, integral of second, minus integral derivative of first function, integral of second, dx. Okay. So if we add integral f dash of x e raised to x dx on both sides and use linearity, then we get therefore integral. So it will be integral e raised to x f of x plus e raised to x f dash x. Okay. So it is integral e raised to x into f of x plus f dash of x dx. Okay, so we are combining these two integrals, this and this. Right hand side is f of x into e raised to x. Okay, so this is simple formula. If we are able to write given expression as e raised to x into f of x plus f dash of x for some function f, then this integral is simply product of f and e raised to x. Okay, let us see one example. Integrate x square plus 1 divided by x plus 1 square into e raised to x. Solution. So this is e raised to x into something. Okay, so we have to write this as sum of f and f dash for some function f. Okay, now we know that x square minus 1 is x plus 1 into x minus 1. Okay, so if we add and subtract 1 here, then the term x square minus 1 will be able to cancel one factor in the denominator. Okay, so we have x square plus 1 divided by x plus 1 square equal to x square minus 1 plus 2. Okay, divided by x plus 1 square. And now this is x square minus 1 divided by x plus 1 square plus 2 divided by x plus 1 square. Now first term is x minus 1 x plus 1 divided by x plus 1 square plus 2 divided by x plus 1 square. So we get x minus 1 divided by x plus 1 plus 2 times x plus 1 square. Now let us differentiate first term. Okay, so if we observe this, then differentiation is clearly this one. Let us see. If we write f of x to be x minus 1 by x plus 1, then f dash of x will be denominator. It is of the form u upon v. Okay, its derivative is v into u dash minus u into v dash divided by v square. Okay, so derivative of u and v both are 1. So it is simply v minus u. So it is 2 divided by x plus 1 v square, x plus 1 square. Okay, so this is f dash. Okay, so therefore this integral e raised to x into x square plus 1 divided by x plus 1 square dx, this can be written as integral e raised to x into, this is f of x plus f dash of x. And by this note, answer is simply product of f of x and e raised to x. So answer is x minus 1 divided by x plus 1 into e raised to x. Okay. Next example. Evaluate we are asked to evaluate two things. First integral, let us call it as I1. This is integral e raised to ax into cos bx plus c dx. Okay. In our earlier examples, everywhere we should write plus c. Okay, arbitrary constant as usual. Okay, so it will be there everywhere. Anyways, so this one and I2 equal to integral e raised to x into sine bx plus c dx, where a, b, and c are arbitrary constants. Means these are real numbers. This can have any value. Okay, this c is different from that constant of integration. Okay. Solution. We use integration by parts. Okay. We have I1 equal to integral. So here this is trigonometric, cos is trigonometric, and this is exponential. So we take first function as cos and second function as exponential. So it is first function cos bx plus c into integral of second, so e raised to ax upon a minus integral derivative of first function. Cos derivative is minus sign, so this minus becomes plus sine bx plus c. By chain rule, the derivative of bx plus c will also be there, so it is simply b. So I'm writing b outside, it is constant. Okay, so derivative of this integral of second is e raised to x divided by a. A is constant, so I am writing outside. So b by a dx plus some constant arbitrary, I am writing c1. Okay. Now, as you can see, this is nothing but I2. Okay. So this is cos bx plus c e raised to x by a plus b upon a into I2 plus constant. Okay. So let us evaluate I2 and then we substitute here. We try to evaluate I2. Now, I2 equal to this integral again. We take first function as sine function. Integral sine of bx plus c into e raised to ax dx equal to first function integral of second function. So e raised to ax upon a minus integral derivative of first function, it is cos bx plus c into derivative of bx plus c, it is b, into integral of second function, it is e raised to ax upon a dx plus some constant. Okay. Now this is nothing but sine bx plus c into e raised to ax upon a minus b upon a, and this is nothing but I1. So this is I1. Okay. Now we substitute value of I1. So it is sine of bx plus c into e raised to ax upon a minus b upon a into I1. So this is I1. So this becomes minus cos bx plus c into b e raised to ax upon this a and this a. So a square. Then minus this b by a. So it is b square by a square I2. And then minus b by a into c1 plus c2, we write it as c3. Okay. So c3 is again arbitrary constant. It is nothing but minus b upon a into c1 plus c2. Now what is our left hand side? Left hand side is I2. So I2 is written in terms of I2. Okay, so what we do? We add b square by a square into I2 in this equation on both sides. Okay, so that our left hand side is 1 plus b square minus a square. Okay. 1 plus b square by a square into I2 equal to these terms. Here we can take e raised to ax common, so that we have sine bx plus c. We can take e raised to ax divided by a as a common term minus cos bx plus c into b by a. This multiplied by e raised to ax upon a plus c3. Okay. Now we divide this equation by this term 1 plus b square by a square. This is nothing but a square plus b square upon a square. Okay, so we get I2 equal to, so here we are multiplying by a square upon a square plus b square. Okay, so that one a gets cancelled and we just have a upon a square plus b square into e raised to ax and this term. And I'm writing here C4 because we are dividing, we are writing here C3 multiplied by a square upon a square plus b square. Okay, so some constant. We don't need to bother about this constant. So our I2 is equal to, now we can simplify this so that it is e raised to ax divided by a square plus b square and we are taking this a inside so that it is a into sine bx plus c minus this a gets cancelled, so it is b cos bx plus c. Okay, plus constant. Okay, so our I2 is this one. So integral sine bx plus c e raised to ax dx, it is e raised to ax upon a square plus b square, a sine bx plus c minus b cos bx plus c. Okay, so this is one formula. Now we can substitute this value of I2 here. Okay, and get the value of I1. Okay, therefore I1 equal to cos bx plus c into e raised to ax upon a plus b upon ai plus b upon a into this. Okay, so we simplify it, plus e raised to ax upon a square plus b square into b upon a into this. So b sine bx plus c minus b upon a. So it is b square upon a cos bx plus c. Okay, plus this constant and that's c1. Okay, so there will be another constant c5. Okay, now we can simplify this. So e raised to ax upon a square plus b square as a common term, and we have b sine bx plus c, and here the term is b square upon a cos bx plus c, and here it should be, okay, we are taking this term common, so it is a square plus b square upon a. Okay, and this is minus b square upon a, so it is a square upon a, so simply a, so plus a into cos bx plus c. So we have integral cos bx plus c into e raised to x dx is e raised to x upon a square plus b square into b sin bx plus c plus a cos bx plus c. Okay, with some constant. So what is difference when we have cos? Here we have plus signs, okay, and b multiplied by sine, a multiplied by cos. When we have sine, okay, integral of e raised to x sine bx plus c, then here we have minus sign and changes this one. So a sine and then minus b cos. Okay, so this is required formula. Okay. So here, example based on this formula, evaluate. First thing, integral e raised to 4x cos 5x dx. Okay, here we can see that a is 4, b is 5, c is 0. Okay, so our formula gives e raised to 4x divided by a square plus b square. So it is 4 square plus 5 square. Okay, so it is 41 into b is 5 sine 5x plus a is 4, so plus 4 cos 5x plus arbitrary constant. Now instead of writing c5 etc., we just write c. Okay, that doesn't matter. C is constant of integration. Second is quite involved. It is integral x square e raised to x into sin x dx. Okay, so here we need to use integration by parts. Okay, but there are three functions. So what we do, we know how to integrate this function e raised to x into sin x. Okay, so we group these two functions and call as z. Okay, so the first function is our f, and these two functions e raised to x and sin x form second function z. Okay, so first we evaluate this thing. Okay, we have integral e raised to x into sin x. Okay, so we use this formula. I2. So this is our answer. Okay, so here our a is 1 as well as b is 1. Okay, so it is e raised to x upon 2 into this one. So sin x minus cos x. Okay, sin x minus cos x. We don't write any constant here because we are going to write constant in the final expression. Okay, so therefore this integral x square into e raised to x sin x dx equal to first function is x square, integral of second function is this one, e raised to x upon 2 sin x minus cos x minus integral derivative of first function is 2x into integral of second is e raised to x by 2 sin x minus cos x dx. Okay, this 2 gets cancelled. Okay, again we have to use integration by parts. Okay, so we need to do these things repeatedly. Okay, Now again we will have e raised to x into sin x and e raised to x into cos x. So we need another formula, that is integral of e raised to x cos x. Okay, so here I am writing in short this, and integral e raised to x into cos x dx equal to, again we use this formula with a equal to 1, b equal to 1, c equal to 0. So it is a raised to x upon 2 into sin x plus cos x. This we are going to use. Okay. So right hand side is equal to x square e raised to x by 2 sin x minus cos x minus here again x into this one. Okay, we treat x as first function, this as second function. Okay, now what is integral of e raised to x into sin x minus cos x? Subtraction of these two things. So e raised to x by 2 is common, sin x minus sin x 0, and minus cos x that is minus 2 cos x. Okay, so that we are going to substitute. So minus, now we write integration by parts, first function x into integral of second, integral of e raised to x sin x minus cos x. So this one, e raised to x by 2 into minus 2 cos x. So here I am writing minus 2 e raised to x by 2 cos x. Okay, we can cancel this 2. So it will be simply minus 1 side. So this is first term integral of second minus integral derivative of first term, derivative of x is 1, integral of second is simply minus 1 e raised to x into cos x dx. Okay, so it becomes x square e raised to x by 2 sin x minus cos x. Now this becomes plus x e raised to x into cos x. Okay, now here this is minus minus and minus 3 times, so it is minus integral e raised to x cos x. It is here, so it is e raised to x by 2 into sin x plus cos x. Okay, we need constant of integration. So here I am substituting, here I am putting plus c everywhere. Okay. Okay. So this is a required answer. Okay. So here we used the formula repeatedly, integration by parts repeated. Next example, again we use the combination of integration by parts and integration by substitution. Okay, so examples which are quite complicated, we need to use more than one rules. Okay, evaluate integral x raised to 5 into tan inverse x square dx. Okay, solution. Okay, here there is tan inverse of x square thing. Okay, so if we want to get rid of this tan inverse of something, then what we do, whatever inside tan inverse, we call it as tan of t. Okay, so that tan inverse of tan of t, it will be simply t. Okay, so this is one way. Okay, so substituting x square equal to tan t, we get 2x dx. Differentiation of left hand side, it is 2x dx equal to differentiation of right hand side, and it is derivative of tan t, it is sec square t into dt. Okay, fine. Now we substitute here. Therefore, we call this as I equal to integral x raised to 5. Again, here we on 2x dx, so I'm dividing by 2 and writing 2x. Okay, and writing this x raised to 5 as x raised to 4 into x. Okay, so this is x raised to 4 tan inverse x square, and this is x and this is divided by 2, so it is 2x dx. Okay, so this 2 here and this is x raised to 4 into x. Okay, now we are writing this as, what is x raised to 4? X raised to 4 is tan square into tan inverse of x square. X square is tan t. 2x dx, it is sec square t dt. Okay, now this is 1/2 integral. This tan inverse tan t, it is simply t multiplied by tan square t into sec square t dt. Okay, now we group this expression as t multiplied by this tan square t sec square t. Okay, so we are going to use integration by parts. So this will be our first function. It is algebraic and this is trigonometric. So this is second function. So what we need, first function into integral of second. So we need to find integral of this thing. So let me call this as expression 1. So first we find integral of tan square t sec square t and then we come back. Okay, now this integral tan square t into sec square t dt. So how to evaluate this? So what we do, it is simple. If we put z equal to tan t, then dz will be sec square t. Okay, so let me call this as I1. Here we put z equal to tan t. Of course, there may be some other way to evaluate this. Okay, so one of these ways is to put z equal to tan t, so that dz equal to sec square t dt. Okay, and therefore our I1 becomes integral tan d is z, so this is z square sec square t dt is dz, and simply our answer is z cubed by 3. We are not putting any arbitrary constants in all these integrals. Okay, finally we will put arbitrary constant here. So it is z cubed by 3 and our z is tan t, so it is tan cube t by 3. Okay, now we use integration by parts in I. Okay, so here this is our first function and this is our second function. Okay, using integration by parts in 1, we get left hand side is I and it is equal to 1/2 into first function is t, integral of second function is this one, tan cube t by 3 minus integral derivative of first function, it is dt by dt, it is 1, so I'm not writing. Derivative of first, integral of second is tan cube t by 3, so I'm writing 1 by 3 outside dt. Okay, of course there will be plus c. Okay, now next thing is to evaluate this integral tan cube. Okay, so we are not done still, so we call this as number 2 and let I2 be integral tan cube t dt. Okay, now we evaluate this thing. Okay, now how to evaluate this thing? So we write this as integral tan t multiplied by tan square t dt. Okay, and now tan square theta is sec square theta minus 1, so this becomes integral tan t multiplied by sec square t minus 1 dt. Okay, so that we can write this as integral tan t multiplied by sec square t dt minus integral tan t dt. Okay, and in first integral we again substitute tan t equal to say u. Okay, so that du equal to sec square t dt. Okay, so if we substitute this as u, then sec square t dt is du. So this is simply integral u du and its integral is u square by 2. Okay, so this is u square by 2 means tan square t by 2. So first term is tan square t by 2. Okay, we are substituting u equal to tan t. Okay, minus integral tan t, again tan is nothing but sin t upon cos t, so we write v equal to cos t, so that minus sin t dt is d. Okay, so this is log of minus sign is there, so minus log of cos t, and we know that constant multiplied by log of something, so this constant will be raised to power, so this is the log of cos t raised to minus 1. That means 1 upon cos t, and 1 upon cos t is sec t. Okay, so log of sec t. So this is we may take modulus of sec. Okay, so without loss I'm writing log of sec t, but it is absolute value. Okay, okay, so this is value of this I2. Okay, now let us substitute back. Okay, therefore I equal to, now we evaluated all the terms and we are writing I equal to So I'm taking this 1/2 inside. So it is t tan cube t by 6. T tan cube t by 6. Now this is -1/6 into this. So -1/6 into this means -1/12. So tan square t by 12. Minus this becomes plus 1/6 log of sec t. Okay, and of course there is constant. Now, what is our t? T is tan inverse x square. So we substitute everywhere, tan inverse x square. So this is t is tan inverse x square multiplied by tan cube of tan inverse x square, okay, divided by 6 minus tan square of tan inverse x square by 12 plus 1/6 log of sec of tan inverse x square plus c. Okay. Now we can further simplify. Okay. So this is tan inverse x square into, now tan cube theta means tan of theta bracket raised to 3. So this is tan of tan inverse x square. So it is x square. X square raised to 3 means x raised to 6 by 6 minus, similarly here x square raised to 2. So it is x raised to 4 by 12. Plus 1/6 log of, now sec theta, it is it can be written in terms of tan, and it is square sec theta is square root 1 plus tan square theta. Okay, so 1 plus tan square theta is sec square theta. So this is square root 1 plus tan square of tan inverse x square. So it is square root 1 plus square of tan inverse x square. So it is x raised to 4. Okay, and plus. Okay, so this is required answer. Okay, so there are such examples shared with you in the Google Classroom. So try those examples. Thank you.